Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem intersection of two arrays. In this problem, we're given two arrays, nums1 and nums2, and we have to return their intersection. By intersection means the elements which appears in both of the arrays, and they must be unique. So the intersection that must not contain duplicate elements. Okay, and the result can be returned in any order. The order of the elements which exist in both the arrays does not matter in the resultant array. Because let's see the input and output format for this problem. So we'll be given two arrays, nums1 and nums2 of sizes n and m, and we have to output an array which is the intersection of these two arrays. And let's see the constraints of the problem. The length of the arrays goes up to 1000, and the elements in each array may go up to 1000. Let's better understand the problem statement using an example. So, as an example, we have two arrays nums1 and nums2, and the intersection part is 4, 9 here because these two elements exist in both of the arrays. Let's see how we can solve this problem. One of the tempting solutions that may come to the mind is to just run two loops. That is, first loop iterates over, let's say, nums1, and another nested loop runs over nums2. And we see if ith and jth element matches here. If they do match, then we push it into the resultant array, and so on. But what is the problem in this approach is that if we have duplicate elements in the array, for instance, we have duplicate elements here, a single element is pushed multiple times. So you can see I start matching 4 with all the elements of this array. So the outer loop runs over this array and the inner loop runs over this array. So for this element, I iterate over all the elements. Then I see, okay, 4 is matching with this. Then I push 4 into my resultant array. Then j is here. 4 is again matching with this. So I push 4 again in my resultant array. So this will create a problem because the resultant array must have unique elements. Hence, this approach, which may come to the mind, is wrong. So let's see how we can solve this problem. The most naive approach to solve this problem is just to use set data structure. So what is a set data structure? A set data structure is basically used to store unique elements, and the elements must be of same type, and they are stored in sorted order. And the complexity for this data structure is logarithmic. The n is the number of elements in the set, and this is the time complexity for insertion, deletion. Okay, and the space complexity is big of n. So let's see how we can use this set data structure. So we push all elements of nums1 array into the set 1, and we push all elements of nums2 array into the set 2. So here we have set1, set2, and this is the pointer I which is pointing to first element of the set, and this is the pointer j which is pointing to the first element of this set 2. Okay, so these are basically iterators, and we compare the elements at I and j. Since they are matching, so I push 4 into my resultant array. Now we move the pointers here. Okay, 5 is not matching with 8, so we move to next element. 9 is matching with 9, then we push 9 here. Time and space complexity for this approach. So you can see that for this approach, the time complexity is n. You can see that the time complexity for insertion of an element into a set is log n, and we have to insert n elements. So that's why n log n. Same for array 2. Hence, m log m, where m is the elements in the array 2. So this is the overall time complexity for this problem. What is the space complexity? Obviously, we are using two sets, this set of size n and this set of size m. Hence, the space complexity would be n plus m. So this is a better solution. This is a basically solution, but the solution uses extra space, so we have to somehow reduce this space. The third approach is sorting plus binary search. So what we do is simply we sort both the arrays So we start iterating the first array. So we start from first element of this array, and this is, let's say, this is the resultant array. Now what we do is we search if 4 exists in this array or not. If it exists, then we push 4 here. Then we move to next element and search. So then we move to this element and we search this element in this array. We see that the 5 does not exist in nums2, so we move to the next element, which is 9. So we see 9 do exist in this array, and hence we push 9 in. Now this is the resultant array. So this is a function find intersection which takes in nums1 and nums2 array as arguments, and here we are calculating the lengths of these arrays and we are sorting the arrays. Okay, so this is the resultant array which will store the final result. So here we are iterating over nums1. For each element in nums1, we are performing binary search in the nums2 array and checking if it exists in the array nums2 or not. If it exists, here this element at mid is matching with the element we are searching for in the nums array, and if it is the case, then we see, okay, if this is the first element that we have found, then push it. Otherwise, if the last element that we inserted in the resultant array is not equal to this, so this condition is basically removing the duplicates for us, which was a problem in the first approach. Okay, because duplicates will appear adjacent to each other, and hence if there are duplicates in nums1, they will be adjacent. So once an element is pushed into the resultant array, it will be checked here. That's the time complexity of this solution. So you can see that we are sorting arrays, and for sorting an array of length n, we take n log n time complexity, and for sorting an array of size m, we take m log n time complexity. For performing binary search, we perform log m, and we are performing binary search for each of the n elements of array 1. So that's the time complexity. Hence the overall time complexity becomes n log n plus m log n plus n log n m, which becomes n log n plus m log n here. And this is a better solution because we are using constant space. We are not using any extra data structure. Now there is another approach to solve this problem, that is sorting plus 2 pointer. So rather than using binary search, we can also use 2 pointers. How? Let's see. So first we sort the arrays. So these are sorted arrays. Then we take 2 pointers, pointer I point to the first element of the nums1 initially, pointer j point to the first element of nums2 initially, and this is the resultant array which is empty. Now we see the elements at I and j, they are matching. We push the element in the result array, then we move the pointers to right by 1. They are not matching. Okay, now we see here that this element is greater than the element here. That means this element will never be found in this area. 4 will never be found in this region because 5 is already greater than 4. This much part of the array. We already traversed this much part of the array. There can be a case that 5 may exist in this region. 4 is less than 5, and if 5 exists in this array, then it must be present to the right of 4, as all the elements to the right of 4 will be either greater than 4 or equal to 4. So that's the logic. Hence we move j to the left and we keep I here. We are not moving I in this. Now we check 5 and 8, they do not match, but since 8 is greater than 5, so we know that if 8 exists in this array, then it must exist here in this region, that is to the right of 5, while 5 will not exist in this region. Hence we move I here. Then we see, okay, 9 is not matching with 8, but 9 is greater than 8, hence 9 must exist in this region, while 8 will not exist to the right of 9. Therefore we move j here. So j is pointing here. Now this is matching with this element, that is the element at j is matching with the element at pointer I. Hence we push this element into the resultant array, and since we have exhausted one of the arrays, there is no meaning in traversing the other array because there are no elements remaining in the first array to match. Hence we quit here. So this is the resultant array. How do we implement this solution? This is just a casework. All we have to do is just to sort the elements and iterate over both the arrays and just use if-else conditions to check for the conditions that I explained here. So this is the function find intersection, which takes in the arguments nums1 and nums2, input arrays. Sizes n and m represents the sizes of these arrays. Resultant array is the empty array. We are sorting the arrays here. These are the 2 pointers. This is pointing to this nums1, j is pointing to nums2, and this is the while loop. So we are iterating over both the arrays, and what we are saying here, okay, if one of the arrays is exhausted, then we quit there. So if the elements match and either the resultant array, we haven't pushed even a single element in the array, then we push this element since this is a matching element, or if the last element that we pushed is not matching with the current element, which is matched with the current element of nums2, hence we push this element. If it does not match with the last element that we pushed, okay, and we move both the pointers in this case because this element was matching and we handled the case here in one of the conditions. Then if it does not match with the element in the second array, then we check if the element in the array 1 is less than the element in the array 2. That means we have to move the pointer to the array 1, move the pointer which is pointing to array 1 to the right, otherwise we move the pointer which is pointing to the array 2 to the right. Let's discuss the time and space complexity for this solution. So here you can see that since we are sorting the two arrays, that takes the time complexity of n log n for array number 1, m log n for array number 2. And for two-pointer approach, we are iterating over the arrays, and in the worst case, this would be the time complexity max of n and m, where n and m represent the lengths of the arrays. Hence, the overall time complexity becomes n log n plus m log n. While the space complexity is constant, we are not using any extra space to solve this problem. So these are the three approaches that I explained here. Let's see the implementation of the final approach, that is two-pointer approach. So this is the implementation in C++. So I'm finding the size of this array, sorting the arrays, and this is where I'm performing the two-pointer strategy to find the intersection elements. Okay, so this is the implementation in C++, and this is the implementation in Java language, and this is the implementation in Python language. I have attached these codes in the description, so make sure to check it out and stay tuned for